we're going to be recreating these 3D cubic fractal designs, all using for loops. It's going to be a little bit mathy, bit nerdy, but by the end, you're going to understand 3 different types of for loops and how to apply them in your own projects. So let's do it.
In the reference that you've seen in the intro, I'm going to dive into quickly what it is and what makes up this kind of complex pattern, if you will. So don't be scared away. There's a lot going on here. All it simply is this pattern that is coming from this grid. So if I zoom out, we're getting this pattern from that grid. So I am going to explain now how I built that. So what we're going to be doing is creating a feedback loop, essentially. And we have our plane here. What we're going to do is select a bunch of faces randomly, and I'm going to go into that as well. And then we're going to subdivide those faces, select them again. This is where the for loop comes in handy. Subdivide them again. So to do that, I'm going to go in and start a new geo container. Let's call it grid. And I'm going to create a grid and just press P to get this menu up for us. It's going to be 4 by 4, and it's going to have 4 rows by 4 columns. And there we're going to create exactly what we had before. And I've got a little selection tool that I've already built in a Wrangle to create what's going to happen next, where I select those faces. So I'm going to paste that in here, and I'm going to just quickly run through it. So I'm going to plug that in. And all I've really got doing is an initialization of the group. So I'm creating a group that I'm selecting, and I'm creating a random number based on the primitive number. So as the seed creation, essentially. So we get a random number per primitive. And then I am pretty much running it through a little process that says if the random number is less than the threshold, and I've created a threshold slider here that is 0.33, which is about 33%. And if it is less than that, then 1. And that's just a random selection process, essentially, getting about 30%. And now it doesn't always get it as I go through the seed, you'll see. And that seed is just offsetting the random number generator. So it gives us a random, different random numbers. And if I come to our primitive here, you can see random number per primitive and whether it's selected or not in our geometry spreadsheet. It's going to close this guy so we have more room. And if I change the seed, you can see the random number changes, which means it changes whether it's above or below the threshold. So we're just going to go seed 0 here for the moment. And then we're going to subdivide. The moment it's subdividing everything, we want to subdivide that group we created. And now it's creating weird stuff. So I'm going to always choose bilinear, which just means it's going to subdivide without smoothing anything. And there we go. We've subdivided some of our faces here. And that's the main process that we're going to be doing here. The main thing where a for loop is going to come into play is when we start repeating this. So I'm going to put this over it and create a little container. And let's call this iteration 01. And let's duplicate that. And this one can be iteration 02. Now, the way a for loop works, and this is pretty much doing a for loop process without doing a for loop, is it's going to run through this process here, and then it's going to feed back into our selection process, which reinitializes the group so everything becomes 0 again, and then it subdivides. So it selects, if I come here, it's going to select new faces. And what we get for free here, which is really good because the number of faces have changed, we get a different random number per face again. So it kind of changes the seed without changing the seed. But we will go into that in a minute as well. And so it's going to subdivide those selected faces. And let's duplicate that again. Run that process through. And again, it's going to select some new faces and then subdivide those faces. And then it's going to, if I create a null here, out. That's what's pretty much happening. So this is what a for loop is if we had a grid running through here, it's going through process 1 and 2, and then it's feeding back into process 1 and 2, and it's feeding the geometry it's spat out back in. And now let's see this in a for loop. This is probably the best way I'm going to be able to explain this is by showing you in a for loop. But this is the main process of a feedback loop. So for loop with feedback. So for loop with feedback is what we're going to create. And what it's going to create is these two things and a funny little box around it. Looks pretty crazy, but it's not. So let's feed our grid into the for loop. If I come here, it's just going to be showing our grid because nothing's happening yet. And if we highlight this, you can see there's not much things we can do here. Fetch feedback and fetch metadata, but just leave that as is at the moment. Fetch feedback is perfect. But if I come down to the bottom here and flag that, we're going to see a couple values. Now, I'm not going to go over everything. We're going to leave iteration method by count for the moment. We're going to go over some of these other options, same with the gather method feedback. We'll go over some of these other options in the other for loops, but for the moment, we'll just leave this as is. And the iterations here, that's when we're saying by count, this is what it's saying, is by each iteration. So if we want to match what we did over here, we did this 3 times, if you remember. So let's make iterations 3. And again, when I look at this, all it's doing is running the grid through here and then feeding that back into the top, running it again and again and again, just 3 times. Simple as that, really. But we have no processes in here. So let's bring our selection and our subdivide. Let's chop that. And let's put that in here. And now you can see it's running it. If I come to this and make this slider move, we're going 0 iterations, 1 iteration, 2 iteration, 3 iteration. And here we go. 0 iteration, 1 iteration, 2 iteration, 3 iteration. And these are exactly the same because if you remember in our selection process, we're not changing the seed or anything between iteration. And that's what this is happening here. It's not changing the seed or anything. But what if we want to change the seed and have more variation? We're not always going to get the new primitives for free, right? So what we might do if we run it through this process is selection 1, keep the seed as 0. Then selection 2, let's make the seed, I'm just going to show you, if I make the seed 1, it's going to change what it selects. And then let's come here and make it 2. Now I'm just doing these as whole numbers. You can obviously do it whatever you want, but I'm doing it as whole numbers because I'm going to illustrate another point that's going to happen within the for loop that can really help you understand what's happening within a for loop and make these two match with very little effort mainly. So what we want to do is be able to pull out what iteration we're currently on as we go through the for loop. Now that information is hidden by default, but how we're going to get it is by highlighting this intro node, going create meta node, which creates this guy. And I love just naming this meta 01, just because it's so much easier to reference and understand later. But what that's doing is it's exposing some details for us. And if we look here when we highlight it, it says detail attributes, iteration, num iterations value, and I value. Now the main one we want to look at here is iteration. And what that's going to do is tell whatever we want it to that what iteration we're on while we're running through it. Now this is going to be all happening in the background, but I'm going to show you how this works. So right now when I click this and click this, they're different because the seed's changing to 1 here and the seed's changing to 2 here. The reason I didn't 1 and 2 is because the way Houdini always works is the first thing is always number 0. So the first iteration that it runs through here is process 0. And so therefore, it's going to push out number iteration will be 0. So let's actually see how that works. I'm going to plug this into our attribute wrangle, mainly because it's going to be easier to reference. And I'm going to come in here and under variable set, I'm going to create a new variable that's an integer. So you've always got to type what it's going to be. And I'm going to call it it, just because that's easy for me to remember, to be perfectly honest, equals. And if you remember in here, it's a detail attribute. And what that is, if you remember back to your geometry spreadsheet, we always have points, vertex attributes, primitive attributes, and detail attributes. Here there's nothing, but when I come in to here, click that, we actually have this stuff exposed for us. Let's find it, essentially. So detail is what we're going to need. Let's open this little bracket. It's going to be in port 1 because, again, it's 0 and 1 up the top here. This is the way Houdini works. And then it's iterations. Or is it iteration? I think it's iteration. Let's have a look. Iteration. Yeah, cool. Iteration. And did I spell that wrong? Probably. I'm just going to copy and paste one I have earlier. Cool. But it's not attached to anything. So on our rando here, I'm going to go plus it. And now when I come in here, we should be looking the same because our seed is going through iteration 0, not changing the seed. So it's saying plus 0. But then when it runs through again, it's going to say plus 1, which is what we changed our seed to be here. And so we're just matching that. You can have more control if you need. But at the moment, I'm fine with this because I've got a seed that's going to change the base. And then that's going to change every single other one as well. And that's exposing how we're able to create this cool pattern, essentially. And we can pump up this number. So this process over here, you can do it, but it's going to get cumbersome when we get to 100 iterations and you have 100 of these guys in your node tree here. So if I come here and keep increasing, we start to get more and more complex stuff. Now, I do want to quickly show you, you might want, and at the moment I am, as you've seen, am doing this and then just selecting any ones which select the ones that are already big. That's kind of what's happening through this process too. But if I want it to select only ones that have been selected, a quick way to do that is create a group and create the group outside because I want to make sure there's a group already existing before the for loop exists. Select O1 and I want it to get everything. So if I come here, cool, it's working. And that means when I come through this process, nothing will change at the moment, but on this wrangle, if I make it only work on a group, it's going to grab the group and then it's going to reset that group so everything is 0 again and then do our process. And that means when it comes back in, it's already looking for the group that we created at the end of this. And then it's feeding back in, looking for that group, only selecting it. So if I come back here and go to iteration, we can see it clearly. Everything's selected. So we make a subset of that in here. And then it will keep that same selection and only subdivide the ones in there. And it's going to create a random selection from them. And then it's going to create a random selection from them and them and them. Now, I didn't like that. So I liked it just being completely random. I feel it gave me a more interesting pattern. So I'm going to remove the group from this. And you can play with the seed here just to get a more interesting pattern, whatever you might like. And this is the basis of the feedback loop. Okay, and before I get into the next loop, I'm actually going to take you through the recipe I got to get to our example at the start. I'm going to show you that here. I have a pre-built recipe that I'm just going to bring in. And we can ignore some of it for the moment. But the main part, what we're going to do is come out of the base that we just created. I'm going to up the iterations to maybe 7 just to get even more detail. And I might change that seed to get something. I'm just going to leave it as is. Let's go with that. Cool. And I'm going to pipe that into the base null here, which is just a nice way to organize our scene. And all I did, if I come through to this node, is I created some noise on Z and called the attribute Z, and that's on each primitive. And I gave a ramp to that noise just so I could have a little bit more control over what it is and change the scale and offset, and also gave it some animation. And if I come to the extrude node, I've just extruded it a bit, and using on the local control, using the distance scale thing here on Z, which is the attribute I created, I'm able to use this noise to drive the extrude. I've also outputted a group for the front, which if I just show you that group now, it's just going to grab the top of all of these guys, which then feeds through here. It grabs them all, extrudes them again, makes them a little bit higher and names them outer layer. And I've also got inner layer being named, which is the stuff that isn't that extruded top. And then that's all coming through here. And I've named them just so I can texture them with ease afterwards. Now, you may notice there's this chunk here. So what that is, and if I feed that through here, is I have a bit of text that I've created, shrunk down, pulled it between the grid that we just made, and then did that same thing with the noise and the extrude. Just I have a different extrusion and I've changed the noise slightly, the ramp on it a little bit more. But the same principle applies, also animating. And then when I bring all that through, we can see we have that text cut out. But one thing I don't like here is it's using the same grid pattern. What I wanted and what I used in the reference is a different grid pattern for the text, essentially. So how are we going to do that? Well, that's going to introduce the next loop. And so let's go with that next loop. And I'm going to explain what that is, that this one is a variation or a merge loop. And how it's going to work is it's very similar to our feedback one, but instead of it feeding back that data into the top and then only outputting once, what this one is going to be doing is going to be outputting at each stage of the iteration. So I'm going to have a little example of that for you. And to do that, I'm going to come over here, make this a bit smaller. Let's create a grid again. Let's make it 4 by 4, 4 by 4. Cool, we got that there. And I'm going to run this through a mountain node. Cool, which is just going to make a cool displacement on our geometry here. Now, how the merge operation is, which I'm just going to create a for loop now, for loop with feedback. If you remember when we come here, we had this option to merge each iteration. Now, how that's going to work initially, and I'm going to do this side by side. So if I'm going to put this mountain node in here and plug this grid in, and let's do 3. How that's going to work is it's like getting another mountain node, plugging it in, getting another mountain node, plugging it in. And so if I do this, they're nearly going to be the same thing, but the difference is normally it would output here. But what we're actually getting with merge after each iteration checked on is it's outputting at stage 1, outputting this one, outputting at stage 2, which is saying add more. So it's feeding back in and it's adding more displacement. And then it's doing that same thing again for third one before it finally, probably guessed it, merges them all together. And these two should be exactly the same. Now, we probably don't want that because what we want to do most likely is to feed this into the nodes individually. So it's not feeding back. So what we had just before was it was going through process 1 and then outputting, feeding back into process 2, outputting again. But what we really want is the grid to kind of flow through process 1, output, flow through process variation 2, output, flow through process 3, and output, effectively creating 3 different variations of the grid. But right now, they're all going to be identical because they all have the same seed. So if I change the seed here or the element, let's do 1 just so we can match these in 2. And now we have 3 variations that aren't feeding back on each other at all. And how we hack that in this for loop is we sever this connection. And now if I come in, nothing's happening because nothing's piping in. And we sever this connection here. And so I get this grid and I pipe that into the mountain node. And again, it's going to be pumping out 3 different variations. But again, like when I didn't change the seed, they're all the same here. So we know how to change the seed, don't we? We're going to create a meta import node. I'm going to call this meta O2. And what we're going to do is apply it to this offset value here. And this one's quite simple. For this one, we're going to need a little backtick, which is next to the number 1 on your keyboard. Then type in detail. And then we're going to need to search for that meta node. We don't just get to type in 1 this time. And how you do that is start opening up some quotation marks, period, backslash, and meta 02 is there. And we named it meta 02 just because it's so much easier. And then close those quotation marks, comma. I want iteration, close that again. And then in this one, I have to press 0 because I believe it needs to find what it's called. It needs the attribute name, and then it needs a float for the index, which is just 0. It's nice and easy. Now it's going to throw an error, and it's probably because I don't need the backtick. Sometimes you need a backtick and sometimes you don't, and I always forget which one. So now we've done that and we've hacked it. So it's applying a bit of an offset to each iteration. There's a cool function here called single pass, and this allows you to see each pass. If I go up higher than 3, because we've only got 3, it's not going to show anything. 0, which is pass 1, pass 2, pass 3, nothing. And this should be identical to this one. Yep. And if I come into mountain node, you should see it's got 2. So this is a good way to visualize what iteration it is. If I come back here and go back to 1, it's going to have 1 there. Cool. Now let's turn single pass off. Now we want to be able to access these because right here, it's just a mess essentially. So what I'm going to do to access these is create a name node, which is just going to create a nice attribute on the primitive. And what I want to do is this time I believe I need a backtick, and I'm going to go detail, and we're going to have to find it again. So let's just copy and paste, hey? Let's make our lives easier. Cool. But I don't want iteration this time because it's just going to say what iteration it's already done. I actually want value, which is kind of the same thing. But as you can see, we've now named our things differently, which allows me to get a blast node and it's automatically merging them for us. But if I want to select one individually, and this is great for doing things like rocks, I can go name 1 and delete non-selected, and it's going to do number 1. And if I do name 2, it's going to grab that. Now, you can probably do this normally with something like this, but if it's a little bit more of a complicated procedure and you also need 100 different variations, this is a really powerful way. Let's kind of quickly show you how I've used this before, and I'm going to come over here to this scatter example. And so what I've done very similarly is similarly, I can never say that word. It's nearly the same. I've created a rock and I've added some mountain to it and I've named it rock 50 or whatever. And I've got 50 different iterations, all which I've colored differently, and it outputs them all for me. And because I severed that, I'm just creating all those different variations. And then I'm able to create a cool mountain node and scatter them all over our grid. So I have 50 variations of a rock, and it just made it nice and easy to be able to pump them out. Now you're probably wondering, yeah, cool, but how's this going to apply to what we're doing over here? Now, if you remember, I wanted a different one for the text, and I wanted a different one for our base. And now I could just duplicate this, and to be honest, I did when I did this myself. But we're learning loops here, right? And this is a good way to show how you can, well, one, do loops in loops, but also we can show you this variation loop. So if I come here, and if I go to the merge where everything is happening, they're still the same. But if I change old mate seed here, we're now getting a different cut of the text. And so let's do that with a loop rather than without a loop. So we can pretty much copy what we have here. And in fact, I'm just going to steal it. So I'm going to sever this connection. And I don't think we need the mountain node. So let's delete that. Let's bring this guy over here. And let's think about it for a second. Again, we need nothing to come in the top, and we want this connection to be still severed, so nothing is ever feeding back. But we want this whole process to exist, so this is where a loop in a loop will come in handy. And so I'm just going to pipe out our for loop and pipe it into the name here. And we're only going to need 2 this time around. And I can get rid of that blast node and pipe that out there. And what that's going to do, it's going to give us two different grids, essentially. And if I go blast, I believe I've got a name 1 and a name 2. I don't actually want this to be called Nate. I want this to be called iteration, or just it. No, let's call it iteration. So that means this is going to be called iteration. And if I blast this to be iteration 1 or iteration 2, they're identical. So if they're identical, what do we want to do? We want our seed to change per loop, second loop. And now let's make this visually make a bit more sense. I'm going to pull this loop over here, push this up there. So now we got 2 loops, and I've got a meta O2. And let's pipe that into our angle, into slot 3, which, if you remember, is slot 2. And so I'm pretty much just going to copy this. And we know it's coming in through port 2, which is this guy here. And it's going to break for a second because we're changing this. So let's call this variable it2. Cool. That should work. But we also need to move it. So I'm going to come in here and go plus it2. We need to change the seed using this variation. Here we go. It's done something. And again, if we want to see it, we can come into our single pass and see the 2 variations. 1, 2. Cool. And if we want even more variation, look, we can go, we can create a little value here, which is float variation equals CHF, because we're creating a channel. I'm just going to pretty much just copy this one here. I'm not going to call it threshold though. I'm going to call it variation. And I'm actually going to plug this above these guys. And then I'm going to say plus variation, which is this one here. And I'm going to have to turn that on. And move, it's plussing nothing. But if I move this variation, it's just going to change our second iteration, which we're not really seeing. But let's realize that that's text and that's not going to work. So let's come here, bracket that guy, and go plus variation. Need to close those brackets. Now everything should work. There we go. And now if I change this, it's going to change the seed just to the second one. Just gives us a little bit more control if we want it. And we turn off single pass. And now let's split these out. So let's create a split. Pipe that in here. And let's look at output 1. First, we need to tell it what to split. I'm going to split it on iteration 1. And then iteration 2 is going to be this one. Cool. So now we've used a loop inside of a loop. And if we come down to our merge here, we can see we've got 2 different types of, and if we come all the way at the bottom, we've created what I created before. 2 different types of grid patterns on our text and our backdrop. or using two loops. And this is a good example of how you can use loops in loops. And I guess for those playing at home still, me creating a name for the outer layer and the inner layer, but also the different variations, has allowed me, and I'm going to quickly go in and show you into my original one. I created a name mix where I merged the name and the iteration number together to create a new variable, which just allowed me to assign materials to different things. So what I did here is I have 3 different materials, and if I come into this, you can see I've got a couple materials in here already done, and I've just assigned to name outer layer 1, which just means the outer, like the top layer, but not the text. And I've given it the white floor. And then if I come in here and say for inner layer 1, which is both the inner layer on the non-text and inner layer 2, which is for the text, I've given it the glass texture. And for the outer layer 2, which is just the top layer here of the loops text, I've given it a wood texture, which when I come back and reopen this, you can see wood texture on the top and the white floor and the glass on everything. And that's how I was able to texture it. So naming these things can be really helpful when it comes to the texturing side of things. And so that's the end of the first 2 loops. Now we're about to get into the third loop here, which we're going to turn it up a notch. So let's jump into this guy and have a look at how he was built. Pretty much what we're going to be doing here in this next mode is using our grid to chop up this sphere. Because if I turn around and have a look at this guy from the front on, it's just our grid, but it's being cut through a sphere. And all those pieces are kind of locked together. Like the top of our sphere here has kind of like an extruded part. And I'm going to show you how to do that. So first, I'm going to break down the steps that we're going to take. I am going to create a geometry node. And this one's going to be sphere. I'm going to go back into our grid that we just created. And I just want the core of this. Let's pull that out. Chuck it in our sphere. And here we go. Here's our neat little grid. I'm going to dial back the iterations on this a bit. Maybe let's change the seed as well. I'm just going to mess around until I get something. Might be cool. So let's visualize what we're going to be doing. When I was creating this sphere, it stumped me for so long. I was just booling it out with a normal bool and it just wouldn't do what I wanted to. But creating this tutorial, and I needed an example of the for each loop, and I realized that I could use the for each loop to create the sphere that I had in my head for so long. And so the for each loop is very powerful. So I'm going to go through how it works and how it's a little bit different than the other loops. So the way the other loops are that are existing here, we've already looked at the feedback loop, we've looked at the variation or the merge loop, however you want to look at it. And the for each loop is a little bit different in that it's going to take whatever we feed it, whether it's a primitive or a point or an object, and do the process to each one of them. So let's visualize that. So we're going to start off with our grid. We're going to select a face, going to pull that out, and then we're going to extrude and center it, or recenter it rather. And then we're going to be cutting that with a sphere. So we're getting the intersection between a sphere and our extruded geometry. And then we're going to get the core. So we're going to make a small sphere intersection just to get a smaller version. And then we're going to get the outer version of that before we're going to merge that all back together. Before finally we do that for the rest of the sphere, as we see here. Now, the example on screen is showing you that this process is going to happen to each and every one. It's going to go to one primitive, run our process, go to the next primitive, and run our process, and so on and so forth. So it's really that simple. So let's do that for our geometry. So I'm going to create another for loop, but I'm going to do for each this time. And the cool thing about Houdini, it gives you a couple different options. They're all the same, all these for each ones, but they just kind of give you some settings pre-made for you, if you will. So let's get this guy in here, and this is for each, and we're going to be using by pieces or points. We're going to merge after each iteration, and we're going to be running over primitives. And if you remember before, the iteration method, we were on by count, which is just however many times. But this time we're doing by pieces, which is rather than having a predefined amount that we want, like 10, it's going to go through each primitive and then stop when it's done all the primitives available. So let's plug this in and run it through here. And you're going to see nothing because we're not doing anything yet. But I do want to quickly run through how we'll be doing or processing all this. I'm going to use the single pass again. And you can see it's just going to select. This is the order that it's going to go through essentially. And this is just because the numbers of the primitive are all out of order. And it's going to go through and select one. Let's just pick this one. Why not? But before we do that, I'm going to back up a little tiny bit. And I'm going to go and create a sphere, which is going to be our, I guess, what's going to be cut. Let's create this at 1.9. And I'm going to bring our grid down a little bit, just to 2 by 2. And so I want the grid to be a little bit bigger than our sphere. And I want our sphere to actually, rather than be polygon mesh, I just want it to be polygon. And let's go 8 intersections. Doesn't matter. It just will be smoother the more frequencies we add to it. And you can kind of already see what's going to happen. We're going to cut our sphere out here, like I mentioned before. And so let's follow the steps we did before. Go back here, select this guy, and let's extrude him. So poly extrude. Extrude him by 2 because that's the size of our sphere. Well, our grid's 2, but our sphere's a little bit smaller. But we're extruding it by 2 because we want it to be a perfect cube when they're all extruded. And then let's reposition him. Transform node. Let's go -1 here. That'll make sure it's center. And if I come here, it's going to be like this. And if I go back to turn single pass off, we can see we've just extruded every face, just like an extrude node would do normally. But we're doing it on individual primitives this time instead of the whole thing in one go. So that's the first step we're doing. Next step will be to bool that with our sphere, our main sphere. So let's do a bool. And it's a bool intersect we want. So bool intersect with our sphere. Boom. Let's go back to single pass so we can see what we're doing. There we go. We're just cutting that sphere and it's nice and neat, which is really good. Houdini has awesome Boolean operations and especially well when it's nice and clean geometry. Now, what we're going to need to do is bool this again. So I'm going to create another one, and this is to create the core, like the inner core. And this one doesn't need to utilize this one at all because we're just going to make it smaller anyway. So I'm going to ignore this one for a second just so we can see what we're doing. And I'm going to create a transform node. I'm going to create 2 actually. So this is going to be how much the crust or the outer ring is going to be down by. So 0.9. And then I'm going to create another one that's going to be how big our bool is going to be happening on our inner ring, which is just going to be a tiny bit more. I'm going to go 0.99. So if we go the difference, I've got this sphere, and then it's shrinking a little bit, and then it's shrinking a little bit more. I might even go just so there's a gap in between them. That's all I really want here. And now if I go back to here, we've bought that. And what I'm going to do is I'm going to create a name because I love naming things like this. It just gives us access to them later. And I'm going to call this inner core. Simple. And I'm going to, instead of put this as name, I'm going to call it layer. And it's going to be on primitive. Now, what we want to do to create our outer layer is use this one and kind of subtract this other sphere that's slightly bigger. So how are we going to do that? Another bool. Classic, right? in this moment. It's going to create a bool. It's going to come out of this one, but it's going to use the second transform, not the third transform. This is going to look a little bit chaotic at the moment, I know, but just bear with me. And if I plug that in, and let's have a look at him, we've got our outer layer. And now if I swap that with the other one, we've got our inner layer. And let's name this one. And we're going to name it outer ring. And again, when we name these things, what's awesome is it pops up in our primitive thing, and everything's just going to be called outer ring that comes through this channel. And now, like I said, we're going to merge them together. So let's plug that guy in there, that guy in there, that guy in there. Let's come back here. And we've pretty much got the process working for us. Now, you might notice one thing that might happen here, and that is the difference between those two sizes. If I just use the same size, they're going to touch. And that can cause issues. So we do like to try and make them not touch. There's no overlapping geometry, especially when you're texturing things. But this one essentially is the control for how big the gap is going to be. And this one is kind of the same sort of thing, but it kind of how big the crust is going to be. So it's completely procedural. If we change this, there's always going to be that much of a gap. And if we change this one to have more of a gap, there's always going to be that much of a gap when we change things up here, which is cool. So I'm going to send them back to where they were. I actually want this one to be a little bit bigger, because I want a little bit more. Oh, maybe 7. Okay, maybe 8. Sometimes you've got to like just play with numbers, right? Now, the next thing we need to do is I want access to the outer ring, the inner core, as I said, but I also want this whole shard to be named something. So we're going to use something that we used before, and that is that name. And I want it to be something to do with the shards. So the name's going to be shard, and let's call it shard here _ And then we're going to do the classic. We're going to need to create a meta node. And this one, meta 03. And we want that meta node to come in here. So that backtick next to the 1. Let's go detail. And then we have to find him, of course, .. / meta 3. Sweet. And then if you remember, we're going to go iteration. Well, if I can spell iteration. Because they're different, the way this one's working is a bit different. We do want it to say iteration as opposed to value, because we're not feeding back. We're just processing, moving on to the next primitive, processing again, where value would give you just 0. So if I go through this and change, we've got different number shard, and it's going to correspond with the single pass thing. So let's open this guy up so we can see. And then we can get rid of this sphere now. And let's turn single pass off. This might take a little second to process, but I might turn on multi-threading just to see. And we've got our sphere back. And it doesn't look like much at the moment because it's just a sphere with a few cuts. But where we're going to be able to see it, if I go explode view, type that in, boom, it's going to explode every piece. But this is not what we want. We want the top and the bottom of those shards to remain in place. So how we're going to do that? Right now it's exploding on name, which there is no name, but we want it to explode on shard. There we go. Now they're connected, which is awesome. This is one thing that I struggled with when I was just doing a normal Boolean, was to make sure the top and the middle and the bottom were all the same number. And then what we're going to do to process him after, get it what the reference was. We're going to need to pack it. And this is just going to pack the geometry. It's going to pack based on name automatically, but we know we want shard. Boom, pack on shard. And then that's going to turn all those pieces, like those shard pieces, including the outer and the inner ring, into just one object that will just have one point assigned to it. And I can just show you that by coming into the viewport here and selecting one of them and go delete. In the delete key, which just creates a blast, and let's delete non-selected. And you can see that's just one point here. So they're all kind of grouped back together. So let's remove that. Now I want to apply some noise to it. So attribute noise. Initially, it's going to color everything. We don't want to color everything. We want P. And we only want the X value of that P. And the more I increase that, especially if I make it 0-centered, the more those things are going to separate away, which looks super cool. And if I shrink down this element size, it's going to look a bit different, which is cool. And maybe I want to animate this. So at 0, it's 0. And let's go 120. Why not? It can be 2. That looks super cool. I love it. I was so excited when I got this one working. And now if I press play, you're going to see it slowly start to slide apart. And we can create some animation on this too. Maybe like 50. Maybe like 25. Let's say 25. Just so they keep moving. Maybe 40. I want them to move slow. I want it to slowly drift. Awesome. Now, if I want to texture this guy, I'm going to need to break him apart and unpack it again. So the only reason I was packing it was so I was able to do this process to it, essentially. There is some ways you can do it without it, but it's just so easy. So why not just pack it and then unpack it? So let's unpack this guy, but not before. I want to also make some randomness. I didn't explain this in any of the other ones, but I want the glass in the middle of this core to change color depending on what shard it is and just have some randomness in that. And so how I'm going to do that is I can just create a noise again, attribute noise, and I want it to be on point. But the cool thing is this is packed, so I want to make this a float, and I want to just call this rando. And it kind of doesn't matter. It's just giving us a random value between 0 and 1. So positive, we're getting between 0 and 1. Let's see, lowest is 0.3, highest is 0.7. Cool, whatever. I'm fine with that. And it's not animating. And then when I come to unpack geometry, I can transfer those attributes back out. So let's transfer rando back out. And you can see that each shard is going to have the same number there on our point attribute. The reason I kept it on points is because I'm using Octane, and Octane can only use points to drive any attributes in a texture. Now, texturing this guy, I've already got some textures that I've made, as you probably have seen before. And one of the reasons I'm unpacking as well, so I can texture it, is so I have access to the inner and outer core. Now, I didn't have to do that. I could keep it packed and do that and pull those attributes out. But I'm just going to show you unpacking how that looks like. And also, in Houdini, it doesn't always handle packed geometry well, so I like to keep it unpacked where I can. So let's create a material node. And come in here, click it, and then material 1, which is going to be, let's go to materials. Let's make it that white floor. I want that to go on the outer ring. And then material 2, which is going to be glass 2. I want that to go on the inner core. And then if I go null here, geo out. Cool. That's done. We've now given those different parts their textures. And if I come out here, I'm going to turn off the other sphere and just look at our sphere. I'm going to need to turn on a couple things. So in the Octane tab, I'm going to turn on attributes, point float, point vector. No. So I'm going to type in rando in our point attribute. And I just realized I didn't do one thing, and that's rotate this guy by -45, so we get that cool offset look. And we can fire up Octane. And let's see this guy, fire up the render, and there we go. And like I said, the randomness is going through the glass through each shard. And that's the same thing that was happening through our grid as well. When I come back here, there was randomness through each little shard, giving you some nice variation. That's how you use for loops. I hope this was exciting, and I hope this was probably not exciting, but I hope it was informative at least, and I hope this makes sense and demystifies some of these for loops, because they can be confusing. that's it.